A quadratic function is a second-degree polynomial function. The graph of a quadratic function is a parabola. If the parabola will open up if a is positive. It will open down if a is negative. At the bottom or at the top we have what's called the vertex. If the graph opens up, the vertex will be a minimum value. It's at the lowest point. If the graph opens down, it will be a maximum value. To find that vertex, we use the vertex formula, which you will find on your formula sheet for Math 150. Our vertex formula will be written as minus b over 2a, comma, f of minus b over 2a. This is x, this is y. Let's try an example. We have f of x equals 3x squared plus 12x plus 4. X equals minus b over 2a. So what is b? Well, this is a, this is b, this is c. So b is 12, so minus b will be minus 12 over 2 times a is 3. We simplify that, we have negative 12 over 6, which is negative 2. So the x value of the vertex is negative 2. To find the y value, we have to evaluate the function at the value that we found for x. In other words, we have to replace all of our x's with negative 2 in our function. So we have 3, negative 2 squared plus 12, negative 2 plus 4. And if you simplify that, that equals negative 8. So our vertex is at negative 2, negative 8. To find the x-intercepts when our quadratic function is written in general form, we use the quadratic formula. So your quadratic formula will also be on your formula sheet. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. Let's rewrite our function here. 3x squared plus 12x plus 4. This is a, b, and c. So we simply need to plug those values into our formula. So minus b will be minus 12. 12 squared minus 4. A is 3 and c is 4. Over 2 times a, which is 3. So x equals negative 12 plus or minus, this simplifies to the square root of 96. All over 2 times 3 is 6. If we want to simplify this further, we need to factor 96. So we'll make a factor tree. Since I'm doing square root, I will look for pairs of factors. I have 2 2's. I can pull one of each pair out. So 2 times 2 gives me 4. So that simplifies to plus or minus 4. Square root of 2 times 3 is what's left over. That's 6 over 6. Now I can divide all of these terms by 2. So to write the x-intercepts as ordered pairs, we would have minus 6 plus 2 square root of 6 over 3, comma 0, and minus 6 minus 2 square root of 6 over 3, comma 0. Okay, that's dealing with the general form. Next we will look at the vertex form or standard form for the quadratic function. is written as f of x equals a is out front, parentheses x minus h, close parentheses squared plus k. To find the vertex when it's written in vertex form is very simple. Vertex is h and k. Here's h, here's k. So let's look at an example. F of x equals 2, parentheses x minus 3, close parentheses squared minus 4. My vertex I can find simply by looking. H is 3 and k is minus 4. Notice that this changed signs and this did not, and that's all we have to do to find the vertex. So that's what's handy about this form of the quadratic function. To find the x-intercepts, we will not use the quadratic formula. We could, but it's more work. We will simply set the function equal to 0 and solve for x. So let's rewrite our function again. So I will, didn't need that there, we would replace f of x with 0. That will give us our x-intercept. And then our job is to simply solve for x. So add 4. Okay, I need to isolate the parentheses, so I'm going to divide both sides by 2. Okay, now I need to get rid of the parentheses, so I'm going to square root both sides. When I do that, I have to remember the plus minus over here. When I square root this, I get rid of everything except what's inside the parentheses. Now if I add 3 to both sides, I get 3 plus or minus the square root of 2 equals x. So to write that as an ordered pair, for my x-intercepts, I would have 3 plus the square root of 2, comma 0, and 3 minus the square root of 2, comma 0. Now, if x ends up being a non-real answer, there are no x-intercepts. So let's do an example like that. This is a different function. Now let's try setting it equal to 0. Now I have to solve for x. I get negative 5. Now when I square root both sides, I end up trying to take the square root of a negative number. That will give me a non-real answer. So for this particular function, there are no x-intercepts.